So now it's my turn to introduce a colleague of mine who serves on the National AI Advisory Committee. She needs little introduction to this group. It's Elham Tabassi. Elham has been a leader in various aspects of responsible AI. She is a senior scientist at the National Institute of Standards and Technology, and was recently appointed as the CTO of the United States AI Safety Institute, which is one of the things that was a direct outcome of the executive order, and has been responsible for leading a number of initiatives in AI, in particular the AI risk management framework. She's been a colleague and a partner. We were delighted to host her here on campus in July. She very much wanted to be here today, but when you're the CTO of the US AI Safety Institute, you get called on and she was unable to be here, and this is one of the reasons why she's going to be joining us over Zoom. And I know I was with her actually just over the last couple of days while on NIAC, and I think we're going to be really excited to hear what she has to say. I'll close by saying she was listed in the inaugural Time 100 Most Influential People in AI, and I'm really excited to be hearing from her. And she brings a perspective that's deeply grounded in technology, but also from her leadership as a vice chair of the OECD Working Party on AI Governance, and a number of other roles, including honors such as being a fellow of the Washington Academy of Science. So without further ado, let me request Elham Tabassi to join us over Zoom.
Thank you, Krishnan, for your kind introduction. Thank you, colleagues at CMU, for inviting me and having me in this event. My apologies, my sincere apologies that I could not be there in person. So many things has been happening and tight timeline all around. But I'm really grateful for the opportunity to talk with you guys, and I will be looking forward to the discussions today. So with that, let me see if I can share my screen. I have few slides to show. I think that's my slides. I'm hoping that you can see the slides. If I can get a kind of a check that you can see the slides. Yeah, I can see the slides on the screen too. Okay, I will be talking and focusing the things that's happening within NIST AI program in the past few months, with a lot of emphasis on the past few weeks. But before I start, many of you may know NIST, but for some of you that you don't, NIST is a federal agency under Department of Commerce with a unique mission of promoting innovations and industrial competitiveness. And we do that by advancing measurement science and standards. So NIST has a very long tradition of cultivating trust in technology. And the way we do that is by participating in development of technically sound standards and advancing measurement science, because we all know if you cannot measure it, you cannot improve it. A little bit emphasis on NIST being a non-regulatory agency, and everything that we do it in close collaborations and engagement with the community. So again, grateful for the opportunity to be here, engage and involved in the work, in the wonderful work that the Block Center at CMU and colleagues at CMU are doing. The way we actually do our work and deliver on the mandates that we get is bring the community together, try to listen to the input from the whole community, and in bringing the community, we make sure that we have a diversity of thoughts and backgrounds. We want to hear from the technology developers, but also the technology users and the community that study the impact of the technology. So we talk and want to learn and get input from computer scientists, mathematicians, statisticians, but also sociologists, cognitive scientists, philosophers, as well as the people, individuals that use the AI technologies are being impacted by AI technologies. We get all of these inputs from many different mechanisms, requests for informations, comments, workshops, conversations such as today. We distill and analyze all of these inputs. You can guess that the inputs that we get is from all over the spectrum, sometimes contradictory advice. So our job is to work with the community, find the right balance that advance the scientific underpinning of the conversations, help us develop the technical building blocks needed for development of guidelines and standards, and then actually get those guidelines and standards into the implementations and implement them, operationalize them, and through all of those things, try to advance the science of the measurement. A sort of a summary of the things that has been happening over the past year. Many of you know that in January 2023, we put the AI-RMF out. That's a voluntary framework for map, measure, manage, and governing of the risk of AI systems. In March, we put a Trustworthy AI Resource Center out to sort of have a space for information sharing. We wanted to be some sort of a hub for all of the authoritative documents and informations about risk management, informative annexes and references for standards, tools that are out there, all with the goal of operationalizing AI-RMF, but also try to be a place for convening conversations. In June, we set up a generative AI public working group, bringing about 2,600 volunteers together to help us draft a profile of AI-RMF for generative AI. It had conversations around evaluations, red teaming, synthetic content, incident disclosure, all of these things being inspired by other disciplines, in cybersecurity, having a sort of vulnerability disclosures have proven to be a very useful tools to share informations and basically help people not to start from step zero. With all of this activity, we got the executive order on October 30th, which gives many agencies different tasks and a good share of tasks to us. The executive order is centered on our obligations to harness the power of AI for good while protecting individuals, communities, and society from its negative impact and the risks that it can pose. I will talk about our assignments within the executive order in a second, but majority of our assignments in the section 4 of the EO around safety and security to develop guidelines for measuring and evaluating safety, trust, security of AI systems, synthetic content, but also we got assignments on developing a global plan for promoting technical standards in international arena. On November 1st, the day after or 2 days after the EO, Vice President Harris announced the establishment of a NIST House, NIST-led US AI Safety Institute. And then immediately after that, we put a workshop out to talk about the consortium that we were building as part of the Institute to provide a convening ground for exchange of informations. Going back to the activities under the EO and our goal of engaging the community, we put a request for information out in December, which closed on February 2nd. We received about 260 sets of comments, altogether more than 2,500 pages of comments. All of those comments will be posted on our website along with a sort of high-level summary synthesis of the comments received. Right now, we are going around attending the listening sessions that the community is organizing. to give us more opportunity to receive input. And I'm really excited to receive input and learn from experience of the community around red teaming today. February 8th, Secretary Raimondo announced the consortium members with 222 members as founding members, and more applications for membership being processed right now. Going back to the executive order, just to give you some idea of the tasks that we have and the deadlines that we have. Executive order gives us, I think in total, something about 9-10 tasks with a tight timeline of majority of those, as you can see, are due on 270 days, July 26th. EO asked us to develop a profile of AI RMF for generative AI, publish a companion document for a secure software framework for generative AI systems and dual use models. We had a workshop on January 17th and a draft being completed right now. The EO asked us to launch initiative to create guidance and benchmarks for evaluations of AI, guidelines for red teaming, provide and make available test environment. And we also have some tasks around synthetic nuclear acid sequencing providers for the security of the biosecurity of AI systems and efficacy of differential privacy guarantee protections. All of, the July 26, 270 day is the deadline for us to develop all of these guidelines, but the work of the EO should not stop there. EO sets a lot of actions in the motion, and through the work of the consortium, through the engagement with the community, we plan to continue these activities, put the guidelines developed as part of the EO, the test environment created as part of the EO, initiatives for evaluations started as part of the EO, continue with putting them into the practice, conduct and run evaluations and challenge problems, including red teaming for the AI systems. The task on a plan for global engagement for promoting and developing AI standards is also extremely important and aligned with our mission and aligned with some of the other administration initiatives for development of the standards. And for somebody that has been decades, more than a decade, working in standard development, it really warms my heart that everybody is paying attention to the standard, because that becomes the backbone of getting all of these guidelines, all of the research that's being done into the actual practice, and through the testing evaluations, advance the safety and security trustworthy of AI systems. So what does the Institute will do? The Institute will lead, I put the USG here, but I think a global effort in science, practice, and policy of AI safety and trust. We all know and agree that we need to be able to evaluate AI systems, and I think majority of us agree that we don't quite know what those evaluations should look like. We, as an institute, have a lot of experience on technology evaluations when we bring systems out of their native of use into the laboratory and test them. As a National Metrology Institute, we have a lot of experience on quantitative measurement, summarizing the observations of the test into a number and measure the uncertainty for those measurements. We all, I think, agree that for measurement of AI systems, we are far away from quantitative measurement and ability to summarize observations into number, and therefore measuring uncertainties the way it's being done for other measurements such as length, mass. So what does the science of AI evaluation should look like? We know that we need to do those model testings, the testings in the laboratories, the testings of the systems kind of divorced from their context of use. We also know that those are not going to be enough, and we need to complement those with stress testings, red teaming, and trying to understand the vulnerabilities of the systems when they are in use. But we think that beyond those, we ought to be able to test the systems in their native context of use, with the humans that interacting with them, operating them, being impacted by them, and the environment that they are being used within. We put that under the topic of build and expand the science of AI evaluations. What are the different steps in AI evaluations? What are the right methodology for those? What are the metrics for testing those? Who are the actors involved? What are the different tests at the different stages of AI lifecycle? And hopefully through the work of the consortium, working with all of the community, including you, we can come up with an interoperable methodology metrics for testing, and we get buy-in and adoption globally. So anybody anywhere around the globe, when they're doing testing, we do it in an interoperable way, and we also report the test results in an interoperable way. So develop guidance and standards is exactly what I just said. Take the results of the output and outcome of the science and bring that into the operation implementations, build a strong scientific underpinning for development of the guidelines, the right technical building blocks for development of the guidelines. So the guidelines and standards are science-based, empirically backed, rooted in the data, which improve the chance of their implementations. Beyond that, again, as the EO talked about, we like to create test environments. One of the problems with AI evaluations, when we figure out how to do those evaluations, is scale. So creating test environment, making them available for public use, kind of leveraging some of the test environments that exist, and again, try to make them all based on the interoperable, harmonized terminology and methodology, so they all do the same thing, can help with scaling of evaluations. And then, of course, with all of these pieces in place, NIST, the Safety Institute, the consortium conduct evaluations, but also provide the tools and in a test environment, test beds for everybody else to do this evaluations. That allows for scaling, that allows for building the profiles and verticals and testing in different domains. So with all that, I'm going to skip this very quickly. The US AI Safety Institute will have the three pillars. First and foremost is research to advance the foundational science of AI safety, AI evaluations, provide the scientific underpinning for development of the guidelines that gets into the implementation and operationalizations with the goal of having metrics, methodologies, test beds, profiles for testing that's interoperable across the field, across the community, and allows for building verticals or testing in different domains. And we won't be able to do that without engagement and bringing everybody together. And that's the work of the consortium. The consortium is, we envisioned this, and we plan to make it a convening place for exchange of ideas, share experiences, and start collaborative projects on advancing all the goals of the institute that I talked about, advancing the science, practice, and policy of AI. The consortium, which the members were announced on February 8, is being organized around 5 working groups, as you see it on the right side of the slide. One on risk management for generative AI, one on synthetic content, capability evaluations, red teaming, safety, and security. They are mapped to the tasks that we have for the EO, again, to be able to give a long-lasting approach to the work that we are doing for the AI. Roughly talking about what this working group is going to do, the first 2 is very, I think, self-exploratory. The first one is development of a profile of AI RMF for generative AI. That's the cross-sectoral profile, building on the top of the work of the generative AI public working group. Synthetic content aligns with the task of the EO that we have, which is the task that we have really is to do a literature survey, kind of a landscape survey, a landscape scan of what are the standards, what are the tools, what are the knowledge in synthetic content labeling, detection, and authentications. As part of the work of the consortium, we may get into development of the guidelines around that. For the 3 working groups, we think that there's going to be a lot of overlap across them. But roughly at a very high level, we think that the safety and security is going to think about address the research part, the building the science part, also thinking about the mitigations plan. The capability evaluations will get the research results, develop guidelines, and the red teaming is the actual activity of the red teamings and also red teaming guidelines. Everything that I said and a lot of the work that we are doing are pretty much aligned with the roadmap that we put out at the time of the release of the AI RMF, which was based on the input and conversations that we had with the community. You would see that the first three activities on the roadmap are around advancing standards, advancing and expanding test evaluation, verification, and validations, and development of the profile or verticals. And I hope you agree that a lot of the work that I just mentioned is heavily around advancing TAB, supporting the measure functions of the AI RMF based on the need of the community. There's a lot of other activities that you see here that are going to be part of the work, the guidance of the human factors, trustworthy characteristics and the trade-off among them, guidance on methodologies for developing reasonable risk tolerance. We will be helping some of the EO tasks on coming up with the minimum risk requirements. So it's while it seems that we have a lot of tasks, which we do, and our plates is really full, the good news is that it aligns with the mission and the work that we were doing, and that we have a excited and committed and talented team to work on this. But we know that we won't be able to do this without the help of the community. So again, excited to be here and look forward to the conversations and learning from you. This is how you can get more information about what we are doing. And with that, I'm going to be respectful of the time of the community, of the time of the event, and happy to answer any questions you may have. And I'll be happy to share this slide with you. So I'm not hearing the room if you're talking.
If anyone has questions, please raise your hand and I'll come give you the microphone. Thank you so much for that introduction. I was curious if you could talk a little bit more about the test environments that you're using today, and what do you see as some of the main challenges to scaling test environments?
Yeah, thanks for that questions. A lot of challenges on building the test environment, characterize, come up with the characterizations of the test environment, what's needed, and the type of testing that needs to be done, right? There are testing that can be completely open, public, open source models using public data, testing of open source model using sensitive data, testings of not open source. And when we talk about open source, they're not really open source, right? I should say publicly available models. And then the testings of the models behind the API. So each of these testings will have there are the different needs for that. So we are just thinking at a high level on this type of testings. The EO asks us for testing of the capabilities that dangerous capabilities such as cybersecurity and biosecurity. So that becomes even more, testing of the algorithms, either open source or behind the API using sensitive data. So that's one dimension of looking at it. The other dimension is those model testing, stress testing, or red teaming, and then the field testing that I talked about. And I think the in test beds and environment for each of those will look a little bit different. The field testing is a lot more complicated. We think it's necessary, but I believe that we can do more work on model testings and red teaming right now in the next few months. But we shouldn't lose sight on field testing. And the last thing I will say is that already there are some test environments and really good activities going on, from ML Commons to AI2 and others. And we will look into how to bring them all together. They are all members of the consortium, and we will get conversations really going on how to how to provide a methodology for testing that they all can test based on those methodologies, so that we have a kind of objective evaluations and not be, the way right now it works is that developers done the testing and share the result of the testing with deployer, but that's it. Can we add more objective testing to the equation? I can get into a lot more detail, and I think one of the things is just get a agreed definition on what we mean by test bed or test environment, and we define it different than NSF defines it. So all of those conversations is going on, and we love to hear your thoughts and inputs on those.
Hello, my name is David Steyer. I'm on the faculty here at Hines. One of my concerns about the use of large language models with open-ended interfaces is that they will be applied to domains which they were not qualified for, essentially, because the data doesn't cover those cases, and it's hard for people to know what the limitations are. Is it within NIST's domain to figure out how to test the competencies of these systems and develop disclosure protocols on what data the systems were trained on?
Yeah, thank you for that questions. And definitely something that we're thinking about, but I just want to double click, underscore the importance of the data used for training. You talked about that gives limitations of what they actually should be, the model should be used and should not be used. But beyond that, I think even for some of the vulnerabilities, and we do the red teaming to figure out, for example, if this can be used for concerns around biosecurity and bioweapon. But we can look at the data that they are being trained on and see if those data exist in the training data, and then make prediction about what it can or cannot do. So I think that the looking at the training data, I believe, should be part of the broader evaluations. A lot of the evaluations are right now just look at the output of the models and don't look at anything before that. What happens if the objective functions, the things about objective function or parameters there changes? What's going to be the effect on the output? So let's just say that yes, these are all part of the conversations. The way you explain the outcome of this, which is some sort of a disclosure on what the model should be used or should not be used, I think NIST is not going to. NIST outputs are all voluntary and try to put information out. So I think we will get into some sort of a uniform reporting of the, I call it, capabilities and limits, but I don't know if it at what level of details it gets. I think it would be very difficult to say that use it for XYZ and don't use it for ABC, but I think there should be some explanations about limits of the model. Thank you for that question. Yeah. I will just also say that about 20 some years ago, I developed a neural network that look at a fingerprint image and say something about the matchability of that. And then I would see in presentation that they run that model on pictures of trees and house. And then the model is trained to give a number. So look at an image, give a number. They were not supposed to be run on the pictures of a tree or car. And they would say that, look, this algorithm didn't realize it's not a fingerprint. I say, yeah, because it was not supposed to be run on a tree or house. And then I learned that, okay, I have to be a filter on the top of it. So I very much relate to your question. That's what I was trying to say.
Hi, Elham. My name is Heather Doman. We've had the pleasure of meeting a couple of times, and I want to thank you very much for your talk today. And I'm very excited about everything that NIST is doing and the consortium and the work going forward. And so my question is really around the interplay between the different areas of the consortium and the red teaming, which we're focused on today, because we know with standards and with the profiles that we're developing, and all of it really does play together. I would be interested in your view around how red teaming might play into and tie to the other areas that the consortium will be tackling as well.
Yeah, thanks for that question. Right now we are working, and we're going to have another deep dive on development of the work plans, which we hope to send it next week. That was another reason I couldn't travel. We envision that the 3 work groups of capability evaluations, red teaming, safety, and security will have a lot of overlap and will be very closely tied together. It is our goal, and I don't want to box myself in, but it is really our desire, and this is what I'm working towards, starting actual evaluations much sooner, right? Because writing guidelines is good and fine, but the guidelines should be tested too, right? We never leave anything untested, and the way of testing the guidelines is actually using them to run evaluations to see if they work or not. So I see conducting this evaluations and trying to do some red teaming exercises, some challenge problem exercises, as a, maybe it's too strong to say, but sort of necessary step to make sure that the guidelines are working well. So we are hoping to start doing more actions on actually running the test. I hope that answered your question. But so we are trying to understand the science, write the guidelines, conduct evaluations, and iterate around this to improve the science, to improve the guidelines, and do better testings.
We have time for one more question.
Good morning. Henry Hargrove, Rand Corporation. I would argue that applying techniques in one field to another is probably one of the great success stories of AI development, trying something new, whether it's fingerprints or trees. My question is, when we talk about red teaming, we're typically, there's a connotation that there's a bad actor. But for anyone that has done autonomy development knows that the operational environment, the real world, presents many challenges. So it's great that you mentioned field testing, which is difficult, along with the sort of synthetic environment. But I wonder if you think that there's going to be an over-focus on sort of bad actor actions that actually might be very rare with these sort of controlled systems, compared to these AIs living in the real world, having to deal with, pedestrians and birds and things like that. Thanks.
Yeah, thanks for that questions. And what you said is why I try to say stress testing red teaming, because when we talk about red teaming, a lot of many of us think about cybersecurity red teaming, which you get adversarial and those the bad actors trying to break the systems. But the AI red teaming, we think of that as broader than that, and sort of stress testing. And not necessarily the bad actors. I think that's part of this, to try to break the systems, but there are other things that, as you said, the birds and trees and the things that may not have been fully considered during the training, or we don't know how they get it into the model, and trying to get the output and response of the models to that. So that gets, again, back to the terminology, right? We use the terms and we have the different understanding of that because it has been used. We borrow it from other domain. That's why working on a shared understanding of the terms becomes really important. Is when we talk about the red teaming, is not really cybersecurity red teaming. So what AI red teaming means, when we talk about open source, it's not really operating system open source that we learned in the past 2 decades. It's a different level of open sourceness or openness to the source that we need to discover. So these are going to be, I think, true to our NIST philosophy of talk about terminology and our fascinations about that. We're going to work on that. Another really great point. Thank you very much.